Hello and welcome everyone. I'm Peter Robinson and today I'm going to talk about OpenZeppelin Contracts. So I'm a technical director and applied cryptographer at Consensus at the R&D group, and hopefully some of my colleagues from Consensus and people generally from all over are going to dive in and tell me when I get this wrong. Okay, let's share some slides. Okay, so hopefully everyone can see my slides now. Okay, brilliant. Okay, so this is going to be a bit of an interactive session. So it'd be great if you had your IDEs available with OpenZeppelin contracts cloned there, and so you can bounce around and then you can say, hey, you're looking at the wrong thing. What about this? What about that? So yeah, that'd be good. And look, I'd like to acknowledge that, first of all, the OpenZeppelin people who've actually created these and all the people who've contributed. Obviously, a lot of work's gone in, so that's great. And additionally, I'd like to thank some people, Joanne, Ermias, Zhenyang, and Sandra, who've provided some feedback and thoughts on the slides and the content. So thank you. So OpenZeppelin is actually a company. And dare I say it, until I'd done this talk, I hadn't actually, I mean, I'd sort of figured it was probably a company, but it might be some, organization or something, but it is in fact a company. And so they do a whole stack of different things, one of which is code auditing, but they seem to have some automated tools for that. And they do all sorts of stuff. And one of the things, and probably one of the main things they do, is the OpenZeppelin contracts. And I think that that's, the thing that they're known for. And so, so the OpenZeppelin contracts is one repo amidst, their multiple repos that they have. And so if you look at that OpenZeppelin repo, you'll get this sort of timeline. And so you've got from the actual repo was created at the end of July 2016, so not too long after the DAO hack. And, it's still very active today. And in fact, when you're looking at open source projects, an interesting thing to do is look at this to see what's the pulse of the project, because if the number of commits to the project have fallen off to 0 in the last year or 3, then you might want to consider whether that project's been maintained or not. So an interesting person, I mean, obviously the Frangio is, one of the main contributor, but Mara Oz is also very interesting because he is the person who did the first many commits to the whole project. And so if you click on his profile, you'll get this, and then you've got that he's got a website. And if you go to his website, it turns out that, so his Manuel Roz, and I'm probably pronouncing that incorrectly, so apologies, Manuel. But so he's the founder of OpenZeppelin, and also he's involved in the Decentraland project. So if you look at the white paper for Decentraland, he's the 4th author on that white paper. So yeah, big long track record and been involved in many things. So what are the OpenZeppelin contracts? So there are a set of contracts that have been written so that you can use for if you want to do something standard, something that, you think, well, golly, am I reinventing the wheel? Surely someone has done this before. Then you can go and have a look at their contracts and maybe use one of their contracts. So either use it directly or inherit it from it. And so they've got a range of things they look at. So one is the token contracts that people use. So ERC20 for NFTs, 721s, or rather ERC20s for fungible tokens, 721s for NFTs, 777, which is an extension of 20, and 1155, where you can have fungible or non-fungible tokens in the one contract. There's also standardized ownable and role-based access control contracts. There's upgrade proxies. They've added recently a governance set of contracts, and there's a whole stack of other helper contracts that they've got. And so that's the idea of the OpenZeppelin project, is you have these these contracts that you can use, and you think, well, you know, they should be good. And so why would you use these contracts? And, you know, why don't you just write your own ownable? Or why don't you just grab something off Stack Overflow? You know, or even better, you know, you look at some contract and you say, well, I don't know, this other big project has used this contract. Why can't I just copy their code and then use that? You know, so why use OpenZeppelin? And so there's a few things. So one is that their code's audited. So in the repo, they've got 2 early audits from 2017 and 18. And then obviously as they've developed their own auditing capability, they've got, you know, they've done their own audits. But so the code has been security audited. There are many eyes on this code. So, you know, we're all looking at the code, all these people in this meetup talk, but then there are, you know, hundreds, if not thousands, maybe tens of thousands of people around the world who are looking at this code. And if they find a bug, you know, they'll probably report it. And so you can get a bug bounty of 25K, or you can just email them directly. Another thing is that the code's actually tested. So there's test code for the contracts. And I know for people from a you know, a more solid or a non smart contract background, you'd say, well, of course it's tested. But I can say that in this space, not everything ends up getting tested. And so having code that you can say at least it's been tested is a good start. It's also documented, which is incredibly helpful. And there's API versioning. So they're aware that, you know, you don't want to just have APIs changing. And they've also continuing to do updates to take advantage of new Solidity features as well. So the primary way of using the OpenZeppelin contracts is using inheritance. So in Solidity, what that means is you have contract, you know, take a name, and then is, and then the thing you're extending or using. So in Solidity, what that really means is you're essentially bringing the source code of that other contract into your contract. And so it's the way to think about it. It's not the overriding and all that stuff does sort of exist. So you can call so from something you could call super dot and then some function to call the function of the same name in the in one of the parent contracts, but it's still a little subtly different in how it works. And so as well as in just basic inheritance and starting to write your own code, you know, deriving from them, you can also use this wizard tool. And I've hopefully got the wizard. Yep, here we go. Here's the wizard tool. And so this wizard tool is something they've created where you say the type of contract you want, and then you say what features you want. You know, do you want role-based access control? Do you want to have it as a minter burner contract? And, you know, say what information do you want to have related to it? And then it'll generate code here that you can use directly for creating your application contract. So it's a very interesting little feature to use, and that's, you know, builds on the actual contracts themselves. And so if you want to say use and have your own ERC20, and assuming you want to use Truffle, then what you do is you install OpenZeppelin. So npm install at OpenZeppelin/contracts. And then you install Truffle and you go npm install -g truffle. So the -g means that you can type truffle from the command line thereafter. Otherwise, I think you've got to type something like npx truffle, and I'm not a JavaScript person. So anyway, if I'm wrong, please some JavaScript person dive in and tell me I'm wrong. Oh, that's good. No one's diving in, so I probably was right. Okay, then you create a Truffle project going Truffle init, and then you create the contract, Truffle create contract, and then, you know, my ERC20, and then you copy, you know, you go back to your wizard, which was over here, and you grab the code, and then you paste it in, you go Truffle compile, create some tests, do whatever you need to do. But so it's very straightforward to use OpenZeppelin.
The only thing, I'll just mention one thing, Peter.
Yep.
Just in that screen, the installation of the OpenZeppelin contracts would happen after you've started up a node project, probably. So, or after your truffle project.
Ah, okay. All right. Okay, everyone, reread that as install Truffle first and then install OpenZeppelin. Yes, because I guess on my machine, I'd had Truffle installed for ages. And so, yeah, okay.
Yeah, so it's like a node project, really. You want those OpenZeppelin contracts probably just in that particular project, and then you can use them in there.
Yeah, okay, and that makes a lot of sense given where I'm going to go on versioning. And so the OpenZeppelin APIs are versioned. And so building off what you're saying, so hence that npm install OpenZeppelin and then specify a version there is going to mean that your particular project is going to be using that version of the APIs. Yeah, okay, brilliant. And so hence you could have two separate projects using two separate versions of OpenZeppelin, which would make
exactly.
Yeah. And so after version 2, they decided that they're going to go with a versioning policy. And so the good thing about versioning is that it means that you can be having your project use, say, version 4.x of OpenZeppelin, and it's not going to break. And so it means the external, public, and internal functions have to obey the same function signature. And so the reason for not just external and public, but internal is because you're extending, you're inheriting from these contracts. So hence you're purposefully using the internal functions. Private functions, they can change as they wish. So events will only ever be added. They're not going to remove any events, and the arguments aren't going to change either. And so if they need to have another event to do something, they'll add a new event. So gas costs. So obviously it'd be lovely if the gas costs went, down, down, down and further down, but they don't guarantee that across, even within a major version, but if they are going to increase gas costs, they really look at it, I think. So there's more details and there are more things that they do around that you can have a look at. As well, the code is BSD licensed. So you can change it however you like, clone the repo, take the parts you're interested in. Obviously, they've got lots of disclaimers about, hey, don't modify, if you're going to grab the code, inherit from it, don't start modifying it, because otherwise, you might get confused about, maybe introduce bugs. And as well, if you are going to clone it rather than using it, you are potentially going to miss out on bug fixes. So let's dive into the contracts. So what I'm going to do is stop sharing there. And I'm now going to share here. Okay. And I use both IntelliJ and the Microsoft one, the Microsoft code. But at the moment, for this, we're going to use IntelliJ. So Joanne, Ermias, Zhenyang, and I discussed where do you start? Because you've got all of these contracts here and, so many possibilities, but probably a good place to start is ERC 20. So the good old token contract. And so what you can see is you've got an interface with a lot of functions, which hopefully everyone by now is very familiar with. And so and you can see a lot of things implemented. But if we go to ERC20, which is this one here, so this is the main body of information, the main implementation of it. You can see that we've got context as well. So it's worthwhile drilling into what these things that you're using are. And so you'll see that they've used message sender and message data. And so, and they just return the standard transaction message sender, message data that you expect. But you'll find that if you're in certain circumstances, you may want to override that. And if we go into this context, then so the idea here is that we're trying to do meta transactions. And so the idea is that you want to be able to say, all right, well, I'm going to send off multiple transactions on this little proxy contract. And so you need to essentially be able to fool what the message sender and message data is. And so you'll see a lot of this underscore message sender underscore message data throughout the code. And then we've also got ERC20 metadata. So that's some extra that you can have, extra things you can have. So their naming convention, I actually hate. But anyway, it is what it is. And so they have underscore, and then the variable name means that it's a variable within the contract, and without the underscore means that it's a variable, like a parameter. So, and we've got a whole lot of extensions as well that you might have. And so if you see draft next to it, then what that means is that it's a draft ERC. And so at some later date, that may get changed across. And so if we dive into, we've got two here that are actually presets. And when they say preset, it means that this is a contract you could choose to deploy. And so preset fixed supply is all about saying, all right, well, this contract is going to have a fixed initial supply, and then from then on, that's it. There's no way of minting more tokens. So you're going to have, say, 1,000 tokens to start off with. And the idea is, though, that you can burn them as well. And so this is an interesting thing to think it through. So do you want to have, so your fixed supply contract, if you use their preset fixed supply, then you're automatically also inheriting this burnable, which means that you have users have the ability to burn their tokens. And so is that a good thing or is that a bad thing? Is this a feature that you hadn't planned on having with your fixed supply? Because now you've got this fixed supply, which can reduce as well. And so, you've got to have a look at what's actually being included in a contract to understand what the total ramifications are. Yeah, but as you can see, similar to if you created your own contract, you would, just inherit from the contracts that you're interested in and then call it. So this here, just so everyone knows, what you're doing is you're passing in initialization parameters to that the contract you're inheriting from, the ERC20. The minter pauser is the idea here is that, so you've got your normal ERC20 on your source blockchain, and then on a different blockchain you've got a minter burner where you initially have no value, and then when you transfer value across, you mint some more tokens. And then maybe when you transfer tokens from the target chain back to the source, then you burn those tokens. And so you can see that it's using something called access control, and it's also pausable. So let's work through pausable first. So with pausable, the idea is that you're adding these events paused and unpaused, and then you've got a few variables that go around, but essentially you've got a function which is underscore pause, which is internal, and underscore unpaused. And so you could work out the logic you want to have, but typically you might have a function which is pause and another function which is unpause that call these two internal functions. And so the idea here is that then you can use the modifier when paused and when not paused to modify the functionality of your code. So if, say, you were having some automatic market maker, maybe if you thought the AMM was under attack or there was some situation, you might want to be able to pause the AMM. So hence you might inherit from pausable. In the Minter burner pausable, you can imagine you've got this ERC20 that can mint or burn tokens, and you want to be able to pause the minting or burning because for some reason or other you think that you're under attack and you don't want to start, minting a bazillion tokens. So obviously, just having only owner for everything is not such a good idea. And so you can use this role-based access control, which is comes from the access control. So there's a range of access control contracts, and the base role access control contract sets it all up for you so that you have a mapping of roles. And then the idea is you have an initial default admin role, which is the admin for all other roles. So it allows you to have this hierarchy of different roles. So you could have, this default admin role, which is essentially your root admin, could control other administrative roles, which could then control other roles, or you could just have a two-level tree where you've got default admin controlling other roles. And that is how it's done here with the Minter pauser. You have the default admin, which you set to message sender, and then you set up a new role, which is this Minter role and pauser role. And at the way this is set up, though, let's drill in here. Yep, here we go. So we're going grant role. And so the user who can grant that role is, so if we go into grant role, has this role got the appropriate, so has this user by account got the role that is needed, and the role that's needed here is to grant other roles. So are they the admin? And if it's true, then it grants that new role. So each role is known by just a bytes 32. And so it's not a big long string or anything, it's just a bytes 32. So if you want to create a new role, you just do a kick at 256 of the string, which defines the role. And so that's how you set up the role-based access control. Okay, let's think about what other things are useful in here. So another interesting one, which I think we've talked about in other talks, but I'll talk about here as well, is the ERC 165. And so with the ERC 165, it allows you to define what the interface is for a contract. And so it allows you to work out, well, does this contract support this interface or this set of functions? And so, and it's got a single function defined, which is supports interface. So if we look, you've got a whole stack of different users of this, but there are two ways of doing it as well. You've got a storage way where you store the actual interfaces that are supported. And then there is, I think it's this one. One of them in here doesn't require any storage, but it uses more processing. Anyway, let's just assume we're using the storage one. And so if based on that, I know we've only got the mock. All right. Let's have a look at, all right, ERC 721 uses it indirectly. So I wonder whether it actually sets up the, oh yeah, so it sets up the supports interface. And so it's going to say that it supports the essentially all of the interfaces that are in that contract. So everything in here, all those function calls are supported. And so you can call with a bytes for which is that value there, and say, well, is it supported? And if it is, then that'll return true. I don't know what 1820 is. Let's have a look. Can implement it. Okay. So who wants to volunteer for talking about 1820? No, right. Let's not worry about 1820 then. That all sounds good. What other ones are interesting in here? So we've talked about pausable. A re-entrancy guard's an interesting one as well. So you might have, we all remember from the DAO attack, that was really a re-entrancy problem where you were able to call and then have once the transfer happened, call back in. And so keep on doing a cycling around and doing a call. And so this has you can have a modifier not re-entrant. And so what happens there is that it works out if the code has been called again. And so so if you set up that modifier, this is how it works. You've got a field, a storage location, and so you read that and say, if that equals not entered, then we're all good. And then you say, right, we're entered, and then you call the function. And then after that, once the function that you were calling has executed, that this modifier is on, then you update the status. And so, you can see that, I guess there's a few interesting things here from a Solidity coding perspective. So one is that I think that often you'll see a modifier which will go modifier, some sort of require, and then it'll just have this underscore semicolon and nothing more, which means essentially copy all the code from the function in here. And so this is an interesting one because it does something after the end of it. The non-re-entrant modifier, you could think, oh, I should put this on all my functions that are non-re-entrant, and that might sound like a good idea, but something to consider is that status is a storage location. And so you're reading from a storage location, then writing to it, and then writing to it again. And so that's going to cost an absolute bucket of gas. You're definitely into even if the storage location is a non-zero value, you're into 5,000 plus gas just for this non-reentrancy.
So I've got a question, Peter.
Yeah.
So if you apply it to one function, it prevents you from re-entering this same function, right? Yep. And if you apply it to all of the other functions, you can't call the function, let's say, a public function twice.
Well, that's true. But if you have one of your functions which might call one of your other functions, then and they're both using the same status field, then it's going to blow up.
But if you have more than one function, you may have an array of statuses rather than.
You could. But I think the idea is, though, that chances are, you've got this code and it's going to do something like a transfer or something. You're going to pass control to some other contract. And the concern is that that other contract calls back into your contract and tries to do some sort of re-entrancy. And that's typically how it happens. So you might actually want to have that single status lock across all your functions, because you want to say, well, you should never be called, you should never have it that you call from my contract to some other contract which is untrusted, and that should never call back into my contract. Yeah. Okay. So any other questions?
So you said you have to use this modifier on the first function that you're calling, on the top one, not on the bottom. Is that it? What I understood, or did I get it wrong?
Yeah, no. So you would have you'd create a. So I'm going to go and put this. Yeah. All right. I'll put it here. New Solidity code. Yeah, Solidity file. And let's add it. Yeah, so yeah, and then okay, so hopefully that, and then we wanted to, so let's go. So it is reentrancy guard, and then what we can do is that we can use this modifier. Actually, am I using that modifier? That's right. I need to import that. Golly, am I using that modifier correctly? With Solidity, it's one of those great languages where you normally copy and paste everything.
Yeah, no, I think that looks right. You may need a modifier on that.
Yeah, it's going to be something like that. Yeah, I think, well, the fact that it's defined it as a modifier. Anyway, and whoops, here we go. Someone's no need for brackets. Yeah, true. No need for brackets. Though you can have brackets actually if you're passing a parameter. So you can have a modifier that has a parameter and you can pass that parameter in. So if you had, yeah, then you could have some sort of modifier where you then pass in that parameter to the modifier as well. So I don't think if it doesn't take any parameters, then you don't need it. Anyway, did that explain how you would use the modifier in this case?
So can you talk quickly about when you would want to use that modifier?
Okay, so you might have, so the use case that they had so with the DAO hack was that they transferred value, and so they were calling, you ended up, if you had a contract, you would have a payable default function that got called, and then it called back in to the original function. And so the idea is to keep on having more and more money sent, and the check that was done after, to essentially update the balance. So I think you would want to try and have this stop reentrancy in a situation where you were worried about things being called back and forth. And Merch has got his hand up, so he's probably got an even better answer.
No, I'm sorry. I was going to ask a question. Please go on.
Oh, yeah, okay. Can only be so lucky, hey. But yeah, look, I think that's where you're at. It's when you call to something that you don't want to have call back to you. But normally, if you think about the ordering of events within your function so that you update state so that you will fail, some require, that's another way of doing it. So it's a hard, brute force mechanism, but it's not the only way. Okay, and so Merch, what was your question?
Let's suppose that I have a function with several parameters, like dates and numbers and everything. Would you create one modifier for each parameter to check them, like is date greater than this, is number, would you create several modifiers, or would you test all these values inside your function and raise something inside?
Yeah, I think so. Modifiers, I think at times get overused. And so for myself, if you're going to have the same check code on multiple functions, having a modifier probably makes sense. But if that check code is only for one function, I'd just have it within the function, because otherwise you're sort of you're splitting your function up, and it makes it complicated for people who are trying to read the code to understand what's going on. And that's why I say is message, is message.sender equals owner, for ownable makes a lot of sense, because you might have a lot of functions that want to worry about being owner. Or another one, say in some contracts that I'm working on around cross-chain, a common requirement is that the user has the minting privilege. And so you could have, or rather the mapping privilege. So you can say only mapping, and then, that's only looking at one thing. If you had, but you could say, be looking at, say, 3 different things, items, and do all the value checking on that, assuming that that was going to be used across multiple functions. Does that make sense?
Thank you, yes.
Okay. So Ron Vander Maiden said, can you talk a bit about the interface ID? Is this a recent new Solidity feature? No, it's been around for a few years, I think. I'm not sure which version it came in, but it's not recent, because the ERC 165 isn't recent. I'm pretty sure the 2 happened there. So, I mean, it was in at that point. Oh, and then Chicha said the same thing. Cool, thank you. All right, so let's delete that before I get too far. Okay, so we've talked about access control, and so you've got ownable in there, which I think even if you're not going to use any other part of the OpenZeppelin, you might as well use this one, because it allows you to have common functions for ownership. I guess the only thing that you might want to look at is, well, you've got things like renounce ownership, which you might not like. And because you might say, no, we don't want anyone to be able to renounce ownership. What you can do is you could extend it, and then have because this is a virtual function, you could have a renounce ownership function at the higher layer that has no implementation and doesn't call down to this one. And that would be a way of cancelling out that. Vesting wallet is another interesting one. And so the vesting wallet, the idea here is that you're going to be given a certain number of tokens or ether, but they're supposed to vest linearly over a period of time. And so you have the beneficiary, the start time, and then the duration in seconds. And so the idea then is that you can call release to release the vested tokens. And so it works out the vested amount based on the timestamp and the amount that have already been released. And then you get sent those tokens. So yeah, and that's just a really simple contract. I'm going to skip over governance for the sec. So interfaces, they're just all the interfaces in one spot, and they just import the actual interfaces themselves. The meta transactions we've talked about. I think mocks are for testing. The proxy contracts are for upgrade and for just proxying through. So you can have a proxy contract to allow you to send through calls. And so what you do is you have this sort of function where you've got an implementation and that you essentially call the call data and call out to, and then you get the return data and you send it back. And so it allows you to do a delegate call to execute code in the storage space of a proxy contract. We've talked about the security contracts, and we've talked about the token contracts, and we've talked about a few of the util contracts. So an interesting one is safe math. And so I know I was talking with Joanne yesterday, and she said that given the most recent version of Solidity has checking automatically, the safe math may not be as useful and needed as it once was. See, and the documentation even says that safe math is generally not needed anymore. There are also various utils for things like manipulating strings as well, which is pretty useful, though you do want to watch the gas costs of all these. All right, so then the one thing that I have skipped over is the governance. So the governance is new stuff, and I dare say it's quite complicated. And so the idea of the governance contracts is that if you want to have a DAO or you want to have voting, then you would use the governance contracts. And so I'm not going to dive into them because I started having a bit of a look and then realized that they were super complicated, and I haven't looked at them before, so I'm not going to go into them. But they are derived from contracts from the compound set of contracts. And so I think, you know, they were, what they said in the documentation was the compound contracts were deemed very useful by a lot of people, and a lot of people started copying them, modifying them a little bit. And so they've made a set of governance contracts that try to allow you to mix and match what governance capabilities you want to have. So stopping share on that, and then starting share on my, I think it's that one. No, that's not it. Sorry, I'll just locate my slides. Yep, there we go. How's about we go back to this slide? Okay, so that was a quick dive into the contracts for OpenZeppelin. So a few thoughts on OpenZeppelin. First one is, don't blindly use their contracts. So sure, they've been security audited and they shouldn't have bugs in them, but they might not actually do exactly what you want. And you know, you certainly want to be watching out for gas usage and just side effects and extra functions that and modifiers that might be in there. So if there's some extra function which is public or external, then it's going to be public or external on your code. So you really want to make sure that you understand exactly what you're getting. And as well, this is not the only set of contracts that's widely used. There's also the Gnosis safe contracts that are also used. And so if you want to continue the conversation, please join the Slack channel and have a chat about the talk. This talk will be available on YouTube. And if you want to join the meetup, so if you're watching on YouTube, join the meetup using that. There is some example code in that repo. And we've got a stack of future talks coming up. In 2 weeks' time, or a little bit less than 2 weeks' time, we've got Lex Sokolin, who's going to give a talk on cryptocurrency pricing. So Lex is the chief economist at Consensus. And so I've got 1 hour of his time total to talk to us. And I think it's going to be very exciting. So it's at 8:40 p.m. on a Tuesday. So a bit of a different time for everyone. We're going to have a few people come along from different blockchain companies and talk about their code and their products. And so, yes, it'll be interesting for people who are especially new to the blockchain space to hear about, well, what are companies actually doing? How does blockchain work for them? In 2 weeks after that, I'm going to talk about gas usage and optimization in Solidity and the EVM generally. And then a week after that, the talk that was going to be today is going to be done April 27 on the merge. And then on May the 4th, we've got a talk from some lawyers. And they're going to talk about the legal implications of ERC 721s, so NFTs. And so, yeah, they're experts in their field, and it's going to be a very interesting talk. And I am going to arrange that Solidity security talk that I said I was going to arrange at some point. So yeah, lots of talks coming up. So I have said a lot. And whoops, and let's stop sharing. And so the question is, are there any questions? Sally, what did you think of it? You've done a fair bit of blockchain development over the years.
Yeah, that was good. I have done a little bit to do with OpenZeppelin, but it was good to get a refresher and get some use cases and dig into some of the details. But yeah, I'm interested to hear what other people are doing with it as well.
So I have one question, Peter. In many instances, so for instance, the ownable and so on, the OpenZeppelin code is 3 times larger than the code that you could write directly in the contract, like requires and so on. And it's more obscure because you don't really know what's in it. So I guess libraries and so on are very useful, but sometimes it's debatable whether you should use it and whether it clarifies what's happening rather than obfuscating what's happening. And in the past as well, I remember some projects 10 or more than 10 years ago in C, the boost libraries and so on, they should have made it to the standard C library. I don't know if they made it, but they were so so hard to use that I'm not sure they made it as the standard library in C. So what's the idea behind? I mean, there's lots of contracts, and some of them seems to be they seem to be useful, and some of them seem to be very simple that you should not use them. You should directly write the code to have a better understanding of what you're doing.
Yeah, and I hear what you're saying, and I think the talk I do on gas usage will be an interesting one because you've touched on a few things. One is more code, more to trying to understand code that isn't, you know, necessarily directly in your code base as well. Yeah, and as well, I think you can, you know, sometimes you can be adding more complexity than you need, and this is the thing. It is BSD licensed. So, say for instance, the access control. If you just want to use access control, you think, well, the way they're doing access control is pretty good, and I could try and write my own access control, but their one obviously works. You could just grab that single contract. And for that matter, though, you could use that single contract, though, straight out of their repo, so you don't have to copy it. I do think this is why I think, though, before you say extend any of the contracts, you really want to fully understand every single line of code that is going to become part of your contract, because I think there's a lot of this is that, and then that is something else, and something else is something else again, and you've got a lot of levels of indirection, so it's quite easy to be dragging in a lot of different stuff.
So I agree with that, but I think that defeats the purpose of this kind of libraries. If you have to understand every detail in everything you're going to use, there's no point having some templates. And there's another thing that I'd like to point out as well. You can write modifiers and so on. You can compose them as well. You can write on a single line more than one modifier. Modifiers can have local variables as well. And the semantics of these things is quite inconsistent. So, I mean, using one, let's say inheriting one feature is okay. Inheriting more than one, they could be unwanted feature interactions. There are semantical issues. You don't really know what the compiler is doing and so on. So that could be really dangerous.
Yeah.
Gas cost you mentioned. SafeMath, for instance, they use when it fails an assert statement, which burns all your left gas compared to a required that will give you the rest of the gas that you have not consumed yet. So that can be really costly.
Yeah, and I think you're right that you've got to. I think you do need to be. I think for any of these things, understanding what the contracts are is important. And I know you said, well, by the time you've understood all these contracts, you could just write them yourself. But if you say, hi, my role-based access control is OpenZeppelin's role-based access control, then when you're having your code audited, or when someone's talking to you about, whether they trust your code or not, you say, look, my code is, 20 lines long or 100 lines long, and it is OpenZeppelin's access control. And then people say, well, I trust OpenZeppelin to have done access control right. Whereas if I wrote, say, 50 lines of access control code, which is going to be smaller, maybe tighter and more targeted to my application, then everyone's going to want to review my role-based access control in graphic detail. So Sam Lewis.
Yeah, Peter,
sorry, go ahead.
I'm probably not the person who's going to be convinced that a lot of testing is enough to
for sure.
be trusted.
Yeah. So Sam Lewis, I can see you've got your video on. What did you think of the talk? What are your questions? Oh, your microphone is not working at the moment.
Can you hear me now?
Yes.
Cool. Yeah, I was just saying, great talk. Still pretty fresh on Solidity knowledge, but it's cool to know that there's these sort of open source libraries out there. I guess that'd be useful even just for reference, even if you're not going to be including them in your own contracts. But yeah, good to know about. All right. Awesome. Thank you. All right, everyone. Have a great week or two, and talk to you all later. Bye-bye.
Thanks, Peter.